Hi, this is Miss Melton. Today we're going to be reviewing all the parts of light that you've learned about in the experiments and the learning. So let's get started. Light. The question was, how does light travel? You learned that from the first experiment. Light travels in a straight line. The greater the distance, the dimmer the light. You learned that from the experiment where you move the flashlight closer and further away from the paper. What is light? We need light to see what is around us. Light is a type of energy. Some light comes from nature. The sun and stars make their own light. Some light is made by people. People make light bulbs. These lights help us see at night. So some light is produced and some light comes from nature. For instance, the moon does not produce its own light. It reflects light from the sun. So everything that does not produce its own light reflects light from somewhere else. So if you look around your room in your house and you see that the light, a lamp is on, an overhead light is on, that's producing light. But everything else that you see is reflecting light from that light source. So if I were to be writing notes about what was important in this unit, I would definitely want to write down light travels in a straight line. The greater the distance, the dimmer the light. So the further away it is, the dimmer it is, the closer it is, the brighter it is. If you want to pause the video to write down these notes in your binder, that would be a great idea. Next, light is a form of energy. Energy is the ability to make something move, happen, or change. So light is that energy. You pushing something, that's energy. Properties of light. So this is how can I describe light? That's a property. So there are 3 different ways to describe light. I can describe it by its brightness. That's the intensity of light. How much amount of light is actually seen? And when you do the experiment, you learn closer to the light, the greater intensity or degree of brightness. The second property is visible. In order for an object to be seen, it must give off its own light or reflect light. For example, the sun, candle, flame, or flashlight give off light. Example, moon, paper, and other objects reflect light. So that's what I was talking about before. If I were to write down notes for this page, I would be writing down light is a form of energy. Energy is the ability to make something move, happen, or change. And I'm underlying things that I know will show up on your test. And there will be a study guide that you'll be able to use and a Quizlet that'll have some things on there, but writing these down will also help you. So properties of light and brightness is the intensity of light. And you already wrote down that the further away, the dimmer it is. So I don't think you need to write down closer to light, the greater the intensity. But if you want to, go ahead. Second is visible. In order for an object to be seen, it must give off its own light or reflect light. So for an object to be seen, must give off its own light or reflect light. And I would write down 2 examples, maybe the sun and a flashlight, and they give off light. Moon, paper, reflect light. And I know I've talked about it with my class when we did astronomy. It came up sun, the moon reflects the sun's light on the moon test, and it also came up on the solar system test. And I told them it'll come up again on this light test. So be ready to know that the moon reflects light, does not produce its own light. Next, the third property is color. White light or white light is made up of all the colors mixed together, and you saw that when we looked through the prism. When white light is passed through a prism, it can be separated into light of different colors. Colors of the spectrum are red, orange, yellow, green, blue, and violet, the rainbow. Each color represents a different amount of energy, and the energy bends through the spectrum at different angles. That's why the white light is separated out. So, a property of light is its color. White light is made up of all colors mixed together. White light is passed through a prism. It can be separated into light of different colors. The spectrum are red, orange, yellow, green, blue, and violet. And people have the acronym of Roy G. Biv to help them remember the colors. And that's actually the order that you'll see it: red, orange, yellow, green, blue, indigo, violet. Next is, so we have properties of light, and now we have the way light reacts when it strikes an object can be different. So for instance, one is reflection. Light bounces off a surface and allows us to see objects. So the light in your room bounces off every object so you can see it. Smooth and shiny surfaces, reflections can be seen. So if you have like a shiny poster, you like if you look at a certain angle, the light might shine back at you very brightly. That's that reflection you're seeing from the light. Or maybe like on your TV screen, you'll get a glare. That's from the it being smooth and shiny. Duller objects often only some light reflects back, so it doesn't have that bright glare. And the color of the light is that's reflected is the color we actually see. So if I'm looking at something that's green, like the grass, the light that's being reflected from the sun is green light is being reflected back to me. That's why I see the grass as green. All the other colors get absorbed, and we'll talk about that in a minute. Refraction is when you saw light pass through one transparent material, like when you put a straw and a piece of in water and glass. So you put one material into another, and then it looks like the straw is bent, that changing direction. Also, when something gets magnified, when you put something behind water in a glass, it looks magnified. If you're out in a river or a lake and you go to pick up a rock and your hand is like bends down and it looks like, oh, it's supposed to be there, but it's actually over one side or another, that's because of refraction. And the last way that light reacts is absorption. So when light does not pass through it or reflect a material, so refraction doesn't happen, reflection doesn't happen, then absorption happens. The light energy remains in the material. So the sun is shining on the green grass, green reflects back to me, that's why the grass seems green. All the other light energy is being absorbed into the grass. So red, orange, yellow, blue, indigo, and violet get absorbed into that grass and stay in the grass, that energy. Colors are made by the light that is not absorbed in, but what is reflected. So for example, you see a red object, it reflects red, and it absorbs every other color. And the bottom picture is a nice picture of reflection in the water of the building. So you can see it better right there. So let's see. Reflection lights bounces off an object, allows us to see. Color of light that's being reflected is the color we see. Refraction, light passes from one type of transparent material to another. Bent. Absorption, light does not pass through or reflect from a material. Light energy remains in the material. All right. Next, so we've learned about properties. We've learned about how they react. Now we're going to talk about light behaves differently when striking different types of materials. So there's 3 ways we can describe that material, not the way the light is behaving, but the material. The material can be transparent, where it allows light to pass through it because it is not being absorbed, or reflected. Objects can be clearly seen when viewed through transparent materials. For example, air, glass, water, those are all transparent. I always think of it like, a parent sees everything, and in the word transparent is parent. So like your parent watches everything you do. It's clearly seen. Translucent is like it's very loose to see. Loose is kind of in there. Material scatters or absorbs some of the light and allows some of the light to pass through it. So objects appear blurry when viewed through transparent materials. So think about wax paper or frosted glass. like in a shower, those are going to be translucent. And opaque material does not allow any light to pass through it. All the light is either reflected or absorbed by the opaque material. So wood, metal, or thick paper. So you can't move the objects, but think what kind of material is this? It is translucent. And the piece of wood is opaque, and the glass is transparent. Now to write down notes, I would say transparent allows light to pass through it. Clearly seen, an example, I'd write down 2 examples, air and glass maybe. Translucent material scatters or absorbs some of the light. Blurry, example, wax paper and frosted glass. Opaque material does not allow light to pass through. Example, wood, metal. Good write down. Now I'm going to review those 3 types of materials. Transparent objects. Many things reflect light, but some things let light pass all the way through them. Transparent objects let light pass through them. A clear glass is transparent. Clear plastic bottles are transparent. We can see what is behind them. We can see what is behind a transparent object, like in this aquarium. You can see the fish through the glass. Translucent things let some light pass through them. They also block some of the light. We can only see some of what is behind them. Sunglasses are translucent. Lampshades are translucent. We cannot clearly see what is behind a translucent object, so it's changing the color, so that would be translucent. And opaque objects. Opaque things do not let any light pass through them. They block the light. Wood is opaque. We cannot see what is behind it. Books are opaque. Buildings are opaque. We cannot see through something that is opaque. So that is a review of all the different things about light that you would need to know and notes that you would need to take.